Okay, so we've been working our way through understanding sequences. And we looked at an arithmetic sequence. So let me try to get you back into your thinking and understanding situations. So let me give you an example up here. Let's suppose we had a sequence A where it went, let's go 1, 7, 13, ... All right, that's an arithmetic sequence. An arithmetic sequence has a common what? Anybody remember? Arithmetic sequence has a common what? Connor? Common difference. Correct. Can anybody tell me what the common difference value is for this one, Andrew? It is 6. So the common difference is 6, meaning each successive number is 6 more than the previous one. Now remember, we'll call the first term a sub 1. The first term. The second, a sub 2. The third, a sub 3. The fourth would be a sub 4, etc., 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 etc. The first term is 1. The second is 7. The third is 13. We have infinite sequences and we have finite sequences. This one is an infinite sequence because of 3 dots, right? It goes on forever, all the way to infinity and even beyond. All right, so it's an infinite sequence. There is no way to sum an infinite sequence because guess what? It goes on forever and ever. However, we can sum, Josh, part of the sequence. We can do that. We can sum part of it, right? Because, Josh, we can't do the whole thing, can we? Why can't we do the whole thing? Because it's infinite, like I just said a moment ago, but you're kind of in Never Never Land today. You need to stand up if it's going to keep you awake and alert, because right now you're not that case. So what we want to do is now, today, we want to learn how to sum up sequences, and we're going to deal with both an arithmetic sequence and a geometric sequence. I'll refresh your memory on a geometric sequence when we get there in just a little bit. That'll be the back half of this lesson. All right, so some notation. So first off, number 1 is summation notation. Summation. S-U-M-M-A-T-I-O-N. Summation notation. And does anybody know the name of that Greek letter? It is not alpha, nor is it omega. It's not theta. Ileana. It is sigma. All right. Now, how did you say it, Ileana? All right. So, do you know your Greek letters? Uh-oh, I'm in trouble now. She knows her Greek letters. And is that like a capital sigma? All right, so there's capital and lowercase, and that's a capital sigma, or at least some kind of a representation of it, depending on who's writing their Greek letters. All right, we use the Greek letter sigma as a symbol to tell you, the algebra student, to sum up a sequence. That's what it tells you to do. You see sigma, you think sum. All right, that works. At least it's alliterate. Sigma and sum. So it's used to represent the sum of the terms of a sequence. Or we could say that the sum of some, S-O-M-E, of the terms of a sequence. Because, again, if it's an infinite sequence, we can't sum that sequence. We'll take part of it. It's really called a partial sum. All right, that's the idea. That's the concept. Let's take a look at the form. Let's take a look at a form. So you got, down below, you got k equals 1. The 1 is the start. You start with a value of 1. What comes after sigma is the general term formula. Also called the explicit formula. General term formula or explicit formula, which would allow you then to figure out the value of any term. What goes on top is the number of terms that you're summing. Number of terms to sum. So with the notation, we know exactly what to do. We know where to start. We know the rule that allows us to figure out the value of any given term, and we know how many terms to go. Right? It's all there, all in one notation. Okay? Summation notation. So let's see if we can put that into practice. So here's our first example. We know the first value to use for k is 1. We know we have to go 3 terms, and we know the rule is 3k. So here's what we're going to do. We're going to start off with 3, and guess what? Where the k is, we're going to stick in 1. And that is the first term. Now, because we're doing summation, I'm going to put a plus sign. And we're going to now figure out the second term. How do we figure out the second term? Again, we put the 3, and where the k is, we stick in 2. We're doing the second term. And we're going to do a plus sign. And again, we do the 3, and where the k is now, we stick in. And then, do we do a plus sign? We don't? We did a plus sign every other time. What do you want, a multiplication sign now? Well, what do you want? Nothing. We're done? Yeah, we're stopping, right? We did 3 terms. First term. It's the first term. This is the second term. And of course, this is the third term. And that's what they wanted us to sum. The first, the second, and the third. So we end up with 3 plus 6 plus 9. And last time I checked, that's 18. So we sum the first 3 terms of this sequence. Summed up the first 3 terms of the sequence. Questions so far? Any questions so far? Okay, so let's look at the second situation. So now we've got case of k equals 1. We got the general term formula or the explicit formula, k plus 7. And we have a 5 up on the top. All right, so I want you to do what I just did a moment ago, only go ahead and apply it to C. I'm going to do it while you do it, so if you're stuck, feel free to look up, but see if you can do it without looking up, all right? Go ahead and see if you can now do sigma for that sequence. I bet you weren't expecting that kind of a sequence. I don't know how you'd add them, but I would add 8 and 12 and get 20, and 9 and 11 and get 20. I'm at 40, and 10 is 50. I don't know how you would add them, but I would definitely add them that way. The commutative property would allow me to do so. Interesting there, with the k plus 7, we started at 1 higher than the 7, and it's just the next consecutive integer. 8 plus 9 plus 10 plus 11 plus 12, grand total of 50. How many you knew what you were doing? You were on the right track there, right? Any questions so far? So again, the rule, k plus 7, will allow you to figure out the value of any given term. If I would use the other notation, the 8 is the first term, the a sub 1. The 9 is the second term, the a sub 2, right? The 10 is the third, a sub 3, etc., etc. We had to term the first 5. So again, same kind of situation there with D. Go ahead and finish up D. Again, I'll do it here as you guys do it there. Do you like your answer? Is your answer perplexing? Okay, that one's 0, right? Just fine. I mean, it just so happens that when you summed up the first 4 terms, you got 0. What would happen if you summed the first 5? What would you get? What's the common difference? 2, right? And so the next number is going to be a 5, right? And so 5 is going to be the sum if you sum the first 5. All right, and on you go. The next one would be a 7. If you sum the first 6, you would get a 5 and a 7 for a 12, etc., right? Just so happens that the first 4 gave you a 0. Not a problem. That's okay. That'll work. Questions so far? You try to understand what summation notation represents. Questions? Clear? Okay, but new, so you're going to have to review to remember. All right. So again, these are called partial sums. Partial, P-A-R-T-I-A-L. These are called partial sums because you're only taking the sum of a part of the sequence. And really, technically, it's called a series, but that's fine. It doesn't really matter. Now, what if we were doing some big amount, like 30 or 90? You'd be like, you got to be kidding me, Mr. Scarfi. I am not going to write out 30 numbers and then add them up. Yeah, I agree. How about if we had a nice, handy-dandy formula? Ooh. Ooh. So, and we do have a nice, handy-dandy formula, and there it is. John.
Is your speaker thing on?
It is.
It is.
It is.
Okay.
Thanks for asking. Yeah, we're good. So, we do have a formula, and the formula does allow us to do everything we need to do, and so we just need to know how to interpret the formula. All right, in this case, the S represents sum the terms. So the S represents the sum. The N is in numbers of places, and of course that's the first term. I'm sorry, the number of terms. I was looking at A sub 1 when I looked at it. Number of terms. Now, let me pause here and say this. Different courses, different texts, different authors like to do things a little differently. In a lot of cases, this A sub 1 is the lowercase a sub 1. They're interchangeable. You'll see it both ways. Our textbook uses a capital letter there, but you know it's common for that to be a lowercase letter. What is A sub 1? The first term. Awesome. So A sub 1, of course, is the first term. And therefore, what is A sub n? I heard it. Say it again louder. Last term. So let's see if we can think about what the formula does, or what it is. All you got to do is take the first term, add to it the value of the last term, multiply by the total number of terms, and divide by 2. And believe it or not, you get the sum. That's pretty amazing. Now somebody figured it out. And you can sit there and play with numbered sums, and you'll see that it works. All right? Don't do this in your notes. Just stop and think. Let's just go through a real simplistic one, and we'll look at it. Let's suppose we had a 5. Let's go simplistic. Let's go 10, 15, 20, 25, 30. All right, so let's just suppose we had that amount of terms, 1, 2, 3, 4, 6 terms. All right, what is the value of n? 6. All right. So the first term is 5. The last term is 30, right? And we're going to multiply, so that's a total of 35. It figures, I had to pick an, here, let's make life. Let's make life. Nah, either way, it's going to be a fraction, so that's life. So we have 35. What's 35 times 6? Can you do that in your head? Use your calculator. 2 times 35 is 70, though. 70, 140, 210. But you can use your calculator if you want. 35 times 6. 210. It is. Divided by 2. 105, right? Add those up. Better be 105. 5 and 10 is 15. 15 and 15 is 30. 30 and 20 is 50. 50 and 25 is 75. 75 and 30. 105. Well, look at that. And look, the formula's not that complicated. First term plus the last term times the number of terms divided by 2. Not so bad. And guess what? It works. All right, well, that was a sequence where we could clearly see the first term, we could clearly see the last term, and we could figure out how many terms there were. For number 1, we don't have that luxury. So to use the formula, we need to know n. Somebody raise your hand and tell me the value of n. Ethan? It is 30, right? Remember, the top number tells you how many terms. N is 30. Now, we're just getting ready to use the formula. We don't have everything we need yet. I need a sub 1. Can somebody tell me how to get a sub 1? Let me give you a second to think about it. How can you get a sub 1? Somebody raise your hand. Ashton?
Do the 2 times 1 plus 1.
Exactly. Ashton says stick 1 in for the K, Earth to Daydreamers, and write 2 times 1 plus 1. Therefore, our a sub 1 is a grand total of 3, right? Good, we needed that value. What else do we need? We need a sub what? A sub what? 30. We need the last term, right? A sub 30. All right, find a sub 30. Find a sub 30. Say it if you know it. 61. Are we ready to roll? We're ready to roll. All right, so again, to help me, and you guys are going to do the same to remember the formula, I'm going to write it first before I sub in. Just takes a second. Well, really about 7 of them. S of n equals n times the quantity, a sub 1 plus a sub n divided by 2. Sub in the numbers, and the rest will be by calculator. But make sure you show me your formula, and then show me the numbers subbed in. So basically, I end up with 15 times 64, right? However you want to do it in your calculator. Make sure you use a parentheses. Make sure you follow order of operations. Somebody gets the answer, raise your hand. Let me know. Raquel? Anybody concur with Raquel 960? And that would be correct. 64 And 30 divided by 2 is 15, so you can do it that way. Or you can do 30 times 64 divided by 2, but you're going to punch an extra button. We get 960. Hey, it's not too bad, is it? Okay, so we're going to do the exact same thing, only this time we're going to sum 99 of them. Woohoo! But again, look, what's n? All right, talk to me now. Talk to me. Go ahead and find a sub 1. Why I find it up here. If you're not sure what to do, you can look up here. Go ahead and find a sub 99. If you're not sure how to find it, you can look up here. And then once you have it, go ahead and run the formula. That was loud. A sub 99. Anybody else get negative 292? Yes? Concur? Okay. All right. Once you have those, we're ready to run it. And again, it's just going to take a second to run the formula. Just remember what the formula is. Add the first and the last, multiply by n, divide by 2. That's not hard. I don't care if you get the formula out of order. As long as you know it, you can use it. Basically, negative 145 times 99, right? Say your answer if you got it. And that's what I heard, negative 14,355, right? Sum the first and the last, multiply by n, divide by 2. Doable? Can you guys do that? Reproduce that? Okay, that's arithmetic sequences. Geometry sequences are different. So geometry or geometric sequences, are different. So an arithmetic sequence had a common difference. What does a geometric sequence have? A common what? Anybody remember? Common ratio. Common ratio. Common ratio. All right, let me show you a basic geometric sequence to refresh your memory on how to get these. So watch. Let's use I'll use Q. And let's go. I gotta think this through to make this work easily. Let's just go with an easy one. Let's go 1, 2, 4, 8, ... That's a geometric sequence. Is anybody able to figure out the value of R? Anybody able to figure out the value of R? It's real simple. All you do is take a term and divide it by the previous term. It doesn't matter which one you choose. It's all the same, right? Because it's a common ratio. What's 8 divided by 4? What's 4 divided by 2? What's 2 divided by 1? What's the common ratio? 2. Any term divided by the previous term. Any of them. So again, you can do it with any 2 you want. If I go 2 divided by 1, I get 2, right? R is 2. Well, that's the only trick in this formula to sum up. But it is a little bit different than the other, is it not? Right? You can see that it's a little bit different. In Algebra 1, I'll give you the geometric sequence formula, but I'll want you to know the arithmetic sequence formula, all right? So on a quiz or a test, if I'm going to have you do the geometric sequences, I'll give you the geometric formula, but I'll want you to know the arithmetic one. Got it? Okay. So in this one, a sub 1, we know that's the first term. 1 is a 1. R is the common ratio. N is the number of terms, right? Everything else the same. We just have to run the formula. Now notice on this one, it's a little bit easier because all we need to know is the first term. We don't need to know the last term to sum this sequence. Okay, so let's go ahead and see if we can do this first example. So S of n equals a sub 1 times 1 minus r to the n divided by 1 minus r. A sub 1 times the quantity, 1 minus r to the n, divided by 1 minus r. Okay, we need a sub 1. Agreed? Can somebody tell me how to get a sub 1? Connor.
3 to the power.
3, and k is an exponent, right? So it's 3 to the first power. Do you agree? All right. K starts at 1. We put a 1 in for the k, and we get 3 to the first power, so this is a 3. So the first term is 3. 1 minus, we got to figure out r. R. Anybody know r for this one? Well, you could do the second term, right? If you want to. What's 3 squared?
9.
Now, how do you get r if you know the first is 3 and the second is 9? 9 divided by 3 is? Yeah, actually, in this format, the base is r. So it just so happens that a sub 1 and r are the same one, because we're trying to give you a simplistic one in the beginning. We don't want to get you too out of kilter in the beginning. And normally these are the way we'll start you in Algebra 1. Okay, so r is 3. And what is n going to be? 7. You guys got to be thinking. If you're just looking and copying, you are learning nothing. If you are looking and copying, you are learning absolutely zero. Zero. You have to think. So I just did the numerator, correct? Just did the top. So what are you going to put in the bottom? Go ahead and put what you're going to put in the bottom. And I hope you put 1 minus 7. Oops, 1 minus 7. 1 minus 3, right? 1 minus r, and r is 3. Okay, go ahead and you're going to have to figure out how to punch your calculator correctly. So you need to do that. Everybody needs your calculator out, and you got to make sure you can get this correctly on your calculator. John, what do you got?
3,279.
It's not what I got. What else? Kirsten, what do you have? It's definitely not negative. 3 and 9 is 12, and you're going to keep going positive from there. It's not negative. Who else has something? Andrew, what do you got? Oh, you know what, John? I'm sorry. I'm looking at the one below it. You said 3,000 what?
279.
I'm sorry. It is 3,279. I was looking at the problem below you. That is correct. 3,279. How many got that? The rest you need to learn how to punch it in your calculator. All right, so that's the idea on these. Just go away, ink. All right, so let's think about a few things. On number 2, what's the value of r? Say it if you know it. 7, right? Again, on these easy ones, the r is the base. What would a sub 1 be on number 2? Why is it 7? Because it's 7 to the first power, right? So that's 7 as well. For time's sake, I'm not going to continue on in that one, but you end up with 6,727,000 on that one.
That one's different than ours. We have an 8.
You guys have a different one?
Yeah.
What do you have, John?
We have for the 30 is 8.
Okay.
And that's
That's the only difference? Okay. So let's see. Oh yeah, I changed mine. Yeah, otherwise the number was too ginormous. So yeah, I did change that to an 8 so that, and then again, you should end up with 6,725,600, I believe, on that one. Because 7 squared is 49, 7 cubed, you're getting up there, 7 to the 4th, and 7 to the 5th, 7 to the 6th, 7 to the 7th, 7 to the 8th. Big number. That's the idea. All right. 3 would be done the exact same way. We've given you just the more simplistic ones of these. Or again, R is going to be 4. So if you're going to do geometric sequences on a quiz or test, I'll supply the formula, but you got to know what things are, and you have to know how to punch your calculator. For the arithmetic sequence, I'll expect you to know what sigma notation means. I'll expect you to know what the parts are, and I'll expect you to know how to interpret it. So you'll have to sum sequences, both arithmetic and geometric. If arithmetic, you're going to know the sum formula, and if it's geometric, I'll supply the formula. Okay? And did I put the numbers, did I put the homework at the bottom? Okay, 1 through 5, 446, again, always short for summation and sequences. Okay, due tomorrow, we'll pick up here tomorrow and deal with division involving radicals.